Question 6. So these formulae are given. So sum to infinity is strictly a over 1 minus r. A is the first term, which is 20. R is the common ratio, that's by how much we multiply each time to get the next term, that's 7/8. So strictly substituting into that, very straightforward, 160. Now for part B, the sum to 12 terms, we're just substituting into this second formula with n being 12, so again very straightforward, 127.8. Now part C is more tricky. Find the smallest value of n for which the sum to infinity less the sum to n is less than a half. Well, we worked out the sum to infinity to being 160. So 160 minus s to the n is less than a half. So rearranging that, we get the sum to n needs to be greater than 160 minus 0.5. In other words, the sum to n terms has got to be greater than 159.5. So substituting in, we get this, and working way through, we get to we get to this. At this point, be careful, we're adding 7/8 to the power of n to both sides and taking away this. So that's why we have the sign change here, because we're basically sort of swapping over sides. Now, I've introduced logs at this point, so n log 7/8 equals log 0.003125. Now, this is the really key point which is easily missed. Log 7/8, if you pop that into your calculator, is a negative. So at this point, we're effectively, well, we're dividing through by a negative number. When you divide by a negative, it reverses the sign. So that's why at this point, we've gone from being less than to being greater than, so n is greater than this log over this log. Pop that into a calculator, we get n being greater than 43.19, so n equals 44. So crucial point on this question is this sign change right at the end.